Okay, in this question, we are going to go into this theory of definite integral and evaluate one integral using the sum, using the Riemann sum. Okay, the question has two parts. Part A asks find Ln. Ln, well, means that find left endpoint approximation for this function. What is delta x? Delta x is b minus a over n, which is 2 minus, this is b, this is a, b 2 minus 0 over n, so 2 over n is that. How about xi minus 1? Let me write it here. Xi minus 1 is a plus I minus 1 times delta x. Very nice. What is a? A is already 0. We know that. I minus 1. What is delta x? Is 2 over n. Well, let's just now put everything that we have there. So I goes from 1 to n. E to the power, this is I minus 1. So xi minus 1. I minus 1 times 2 over n. And delta x is 2 over n. Okay, this is the first step. The question as find Ln means that evaluate it and write it in terms of n. Okay, so we have to find the sum. First thing you have to notice is that, well, the integrating, well, the summing index is I, and this term 2 over n has no I in it. So I can take it out and put it outside as multiple. And this is 2i. Okay. Here, you might say that, okay, how could I do this? The key point here is that what is called geometric series. Geometric series is that when you go from from 1 to n, b to the power I. Okay. If you have that, there is a sum formula for this, guys. B is any constant with respect to I, and then to the power I. So the formula says that you have b to the power the upper 1 plus 1 minus b to the power 1. And then in the denominator, we have b minus 1. So this is the geometric series, and we need that, this geometric series formula, and we need that here. But if you look at this guy, there is no b to the power I. Well, I can make that by doing this. You first see that this is 2 to the power 2in e to the power minus 2 over n. I multiplied this in, and I use the property that the difference of exponent, your sums of exponent gives us the product of the terms. And here now, this term has no I in it. I can take it out and put it outside. So it will be 2 e to the power minus 2 over n. Sum goes from 1 to n, e to the power. I want to write it as this, something to the power I. I can do like this. I can write it here to the power I. Now, I have the b that I was looking for, and that's b to the power I. This is power series, and I can use that formula. So this sum is going to be 2, let me write Ln, is 2e to the power negative 2n over n times b to the power n minus 1. So e to the n plus 1. b here is e to the power 2n to the power n plus 1 minus b itself, e to the power 2 over n, over b minus 1. Okay? We found a formula which only involves n, and it doesn't have any I in it. Okay? I can multiply this guy inside and make it even a little bit more clear. So if I multiply this inside, you see that the first term cancels out. So I will have 2 over n e to the power 2n minus 1. And when I multiply this term there, I will get e to the power, what? Actually, you will get e to the power 2. When I multiply to the second term, I'll get e to the power 2n minus 2 over n, 2 over n minus 2 over n. So that will e to the power 0, which is 1. Here, maybe you may ask what did happen there. So I multiplied this to this guy. And this is the same thing as this, times e to the power 2n plus 1 over n. And this is equal to e to the power negative 2 over n plus 2n over n plus 2 over n. These two cancels, this cancels with that, and that's how I get e to the power 2. So this way, I found a formula for left end point approximation of this function for on the interval 0 to 2. Very nice. That's part A. The question asks, find the value of that definite integral. We know that the definite integral is, if the function is continuous, which is, this is e to the power x, this is limit of ln or rn, both will give you the same number. Here, what we have is 2e to the power 2 minus 1 over n e to the power 2 over n minus 1 as n goes to. Well, this, you can turn it to x and try to evaluate, but what you have to notice that the numerator is a number. It's just there. What I have is in the denominator, I have to evaluate this guy as n goes to infinity. Well, and if you do that, this part n will give you infinity. E to the power 2 over n, n goes to infinity, 2 over n goes to 0. So e to the power 0 is 1. 1 minus 1 is 0. So what we have is indeterminate form 0 times infinity or infinity times 0. That's the same thing. Yeah. So what should we do? Okay, to be able to handle this, first, I kind of like to work with x's. The reason is that usually I take n for working with natural number or integer numbers. But now I want to use something which we discussed before, which is Labtube. Here, I can do e to the power 2 over x minus 1 over, I write x as 1 over x. And this way, when you look at this limit, this will be 0 over 0, and right away we can use Labtube. And this gives me derivative of the numerator, which is negative 2 over x squared e to the power 2 over x. Limit of the denominator is negative 1 over x squared. This thing goes away with this. In the numerator, what we would get is limit of 2 e to the power 2 over x as x goes to plus infinity. And look at this guy. I know what to do with this. E to the power 2 over x, x goes to infinity is 2 e to the power 0, which will give me 2. Now that we computed the limit of the denominator, I can come up and write that, apply the quotient law, and just write it there. Well, these two cancel out. And what you get is e to the power 2 minus 1. And that is the value of integral of e to the power x from 0 to 2. You will see, we will learn some more tools later on that will help us not to go and not to be worried about all these work that we have done. We'll be like that to evaluate an integral of the given